Hi everyone, I'm Denise Ellington from 32Soft. Welcome and thank you for attending MRP, How to Make It Fail with Don Lindsey. Hopefully many of you know Don already from our monthly webinars, as he is a guru in all areas of QAD, with extensive experience as an analyst, project manager, presenter, and trainer. Don's training includes more than 20 years at the Apex program at California's State Fullerton. With his diverse background in varied manufacturing industries, Don has more than 18 years of QAD ERP experience and has worked with 7 different versions of QAD. We do hope you'll stick around after Don's presentation for the live Q&A. Don will also be on hand at our 32Soft booth if you'd like to pop on over to chat or join any of our Ask Me Anything sessions. And now, the man, the myth, the legend, Don Lindsey.
Thank you, Denise, for that nice introduction. As Denise says, my name is Don Lindsey, and I'm a business analyst with 32Soft. Been involved with the supply chain for many years, and about the last 18 directly with QAD. I've taught the Apex certification courses at Cal State Fullerton for 25 years, and I am certified as a fellow and certified in resource management. Jeff Sheldon, our coordinator, had sent this, and we want to make sure that you know there is a chat feature available. There's a Zoom link, and there's a session survey. So what is the purpose of our presentation today? Well, the title is MRP, How to Make It Fail. So we first of all want to understand how QAD works, and then what causes MRP to work properly. If we understand how to work it properly, or what makes it fail, we can better use material requirements planning to successfully build our plans. As I've said almost every webinar that we give, there are many terms and definitions for MRP that you're going to have to become familiar with. We recommend that you have a solid set of work instructions and that you have a company wiki or a data dictionary, because all of the terms that we use, sometimes I'll use terms that are not familiar to you, but your organization use a term that doesn't make sense to the rest of us. So we want to make sure that we've got a common understanding of what material requirements planning needs. Just a reminder that MOGLI, the Material Management Operational Guidelines and Logistical Evaluation, requires work instructions and data dictionaries. So just a quick word about ERP history. I've talked about this in several of our webinars before. It was conceived in the 1950s with the introduction of the BOMP, the Bill of Material Processor. That was invented by IBM, and it allowed the statement of a parent and component relationship in terms of bytes and bits. In the 1960s, small group of practitioners led by Joe Orlicki, Ollie White, George Plossel developed MRP, the time phase explosion of that bill of material. And during the 1970s, it was basically commercialized, SAP, Oracle. And by the 1990s, most manufacturing companies have an ERP system that has MRP as its embedded planning system. So MRP has become basically a way of life in planning for ERP. ERP is part of what is called the MRP2 or ERP system. ERP, the term was coined by Gardner back in the 1980s, and basically is the enterprise resource planning system in which MRP resides. It starts up at the top with business planning, marketing planning, and production planning. We check our resources. If our resources are adequate, then we drive that down into the master schedule. Master schedule drives into MRP and capacity planning. And then if the detailed plans are validated and in concert with the SIOP process, the business planning process, then we execute down into shop floor control, purchasing, and cost management. So there's a closed loop system. There are a whole lot of other accoutrement software functions, applications that play into ERP, SIOP, CERM, warehouse management, manufacturing execution systems. These are all part of what Gardner now calls the enterprise resource plan. But at the center of it is this thing called MRP. This is the basic tool for scheduling within our MRP ERP system. If we look at QAD, QAD has all of those functions detailed out in the .NET environment. There's the high-end sales order, sales management, customer management, supply chain has purchasing, EDI, operations plan. There's the manufacturing modules that include product structure, routings, work centers, forecasting, etc. And that is where we find material requirements planning within the QAD network. Then there's items, inventory, addresses, and then finally the financial applications, cost management, general ledger, AP, AR, etc. So QAD has got all of those tools that we need to execute our ERP and MRP functions. Let's take a look at some of the elements of MRP. First of all, is this thing called a BOM. This is the bill of material processor that was invented back in the 1960s, and this is that time-phased explosion of the bill of material based on the master production schedule to determine what and when product needs to be procured and built. We can look at a couple of ideas around this bill of material. There is this parent-component relationship, the BOMP that we talked about, and here we have a simple product structure. A takes B, C, and D, B takes E and F, C takes G, and E takes G, F, and H. So as opposed to what you might think that a bill of material system is, it's not a parent and a list of components. What the actual PS master is this parent component relationship that we define in 13.5 and 15.5. So in this particular bill of material, we have 9 of these parent component relationships. There are vertical and horizontal relationships that are defined within that product structure. We have the purchase components. These are the items down at the lowest level. This is what we order from our suppliers. And then we have assemblies A, B, C, and E represented as the parents along with their requisite components. The low-level code in this bill of materials system is defined as the lowest level that you will find an item in any bill of material in the system. This means that if we look at G, for example, this is at low-level code 0, A or a 3, A0, B1, E2, G3. And so what this allows us to do is to calculate through this BOMP process the numbers of G's that it takes to build an A. Well, it's going to take 24 G's to build that A. So we can take that bill of material and those concepts, and looking at a simple bill of material, if we take that bill of material and we turn it on its side, basically we can see how MRP works. If we have a final assembly that has a due date, that due date is offset back to when it needs to start. So in this case, subassembly B and subassembly A need to be available when final assembly begins. So that is the start date of the final assembly, but the due date of the subassembly. So you can offset from that due date again back to the start date of its components, and you just kind of walk the system back through that due date, off date, start date process so that MRP now has exploded its time phase explosion of the bill of material. This calculates to give us what is called the cumulative manufacturing lead time. We'll talk about that in just a second. So we find that bump defined in 13.5, but you can also define other kinds of bill of material structures and formula structures by use of what is called the product structure code maintenance. This creates parent-component relationships for planning bills, common bills, alternates, other kinds of product structures that exist within the MRP environment. So if we look at 13.5, we can see that the parent, this is defined in the item master, this is the parent item of a particular or this particular product structure. It has a component, and it also must be defined in the item master file. And it's the components that are used directly in that level parent-component relationship. So this component is going to have a low-level code that we talked about in terms of that product structure. There's a start and effectivity date. This is the first date of the product component, and we know that this relationship becomes effective, and please use that. I worked with a couple of companies that didn't have that start date defined, and MRP doesn't work very well without that. The next is the quantity per. This is probably the most critical piece of information in the ERP system, I would say. It is critical to the operation of MRP. This is the quantity per of the child as it relates to the parent. So this is the quantity per. There is a structure type defined in 13.5. Structure type can be blank. That's just a normal parent-component relationship. You've got alternates, docs, co and byproducts, local phantoms we'll talk about later, planning bills, and option bills. So the basic MRP parent-component relationship will have a blank structure type for that relationship. If you put in a start effectivity up in the top frame of 13.5, it allows you to modify the start and end effectivity dates of that particular parent component relationship. There is a scrap factor. We'll talk about the scrap factor in just a second. This increases the gross requirement of that particular component, but doesn't show specifically in MRP, and I'll explain that in just a second. There's a lead time offset that's defined in 13.5. This happens when the lead time of the requirement for this particular component is different than the standard lead time that is defined in 1.4.7, the item master, or 1.4.17, the item site definition. And it can be negative, it's not. So why is the bill of material so important? Well, it gives us our structure. It tells us the timing of that bill of material, defines the cost of those items that we're producing. It allows us to forecast and use forecast at the end items or those items that have independent man, which we'll talk about in just a second, and the build process. This is the basis of work instructions for the routing. So the BOM is critical to the operation of MRP. Formula maintenance can be done for a parent-component relationship. This is sometimes referred to as a recipe or batch. This basically is the same thing as a parent-component relationship in a bill of material, only it has what is called a quantity type. If we use blank, same as a 13.5, but you can also have a batch size or a batch percentage. This is one of the reasons that the life science companies love QAD, because you've got this capability of finding recipes. Phantoms. Phantoms in product structures are basically what are called blow-throughs or phantom assemblies. You can have either a global phantom, which means that it is at the item level, so that for all bills of material, you have a blow-through or zero lead time, a lot per lot, and MRP will plan those orders. Or you can define what is called a local phantom, just on the 13.5 product structure maintenance. If you use a product structure X, then you can define that just on that particular parent-component relationship. We often say that phantom structures are planning's guard against overly structured bills of material. I remember one example. We had a piece of glass that was ground for a microscope, and the manufacturing engineers had 7 different drawings for this particular blank, and then cut, and then, but they were all done in the same physical work center. And so those 7 product structures, we could then blow through those and just say, for the requirements, give me the blank. Work much better. So the reasons that MRP can cause issues in MRP, or that BOMs can cause issues in MRP, are incorrect statements of parent-component relationships, inaccurate quantity per batch, the failure to use batches and formulas in the most appropriate places, the incorrect use of structure types, not using start and end effectivity dates, scrap and yield, I'll talk about, lead time offset, I talked about, forecast percentages, and the phantom logic. Those are all reasons that BOMs can cause issues in MRP. The last is the update of engineering change processes. Product change control, life changes in manufacturing. New parts are created, improvements in production, error correction, modifications. It's just a constant change of manufacturing for those of us who live in that environment. QAD gives us 1.9, which is product change control, and this has to do with groups, routing slips. We can have product change requests, product change orders. We can incorporate and implement these product changes. So if you don't use the product change control mechanisms, there's also Arena, Wind Chill, Agile, a lot of us use. So you've got to have those kinds of product changes incorporated in your MRP data, because if you don't, your item data may change, your BOMs may change, not control work centers may not be reviewed, routings might have incorrect statement of processes, sales order dates and specifications may be incorrect, work orders, purchase orders may not be updated, and then inventory obsolescence and usage is not incorporated if you don't have a product change control in your environment. Let's talk a little bit about lead time. We saw that the bill of material, we saw the start date and the due date, and this thing called the offset. Well, that's the lead time of the particular part in our bill of material explosion. So the lead time definition is the time from when we need an order and it's recognized that we need it through the placing of that order until the part is ready for use and received into inventory. This is defined primarily in the MRP planning element in 1.4.7 and 1.4.17, and that is a constant process of measuring between the planned lead time and actual lead time. One of the primary responsibilities or tools that makes MRP effective is if those planned lead times are as close as humanly possible to actual lead times. So we go through the explosion process. This is the bill of material, that BOMP we talked about. And then the offsetting is based upon the requirements in the difference between the due date and the start date. That is the offset of these. Plans should be close as actual as possible. Calendars in QED. You must have calendars to help MRP look at the relationship between dates. The calendars are defined in 36.2. Holiday maintenance is defined in 36.2.1. And this is another reason that I see MRP systems failing, is the inability of the system to recognize the actual dates and hours and holidays that the system is going to be operating. So there's lead time elements in manufacturing. The manufacturing lead time, made up of 5 elements of lead time: queue, wait, setup, run, and move. You can use the 14.13.13 routing cost rollup to use those wait, queue, setup, run, and move times to calculate the lead times. If you don't have accurate routings, I'd recommend you stay with the statement of the lead time in 1.4.7 or 1.4.17. There is the purchase lead time, inspection lead time. Those are going to play in your MRP lead time explosion. And then, as we talked about the effect of MRP, the failure to track actual manufacturing lead time. These are one of the primary reasons why MRP may not be giving you the correct scheduling processes. We talked about cumulative manufacturing lead time. That should probably set up in a batch to run every night. And then if you use time fences, I don't have time to talk about time fences, but the frozen periods in 1.4.7 and 1.4.17. And then your definition of your MRP horizons in 23.14, the QED. So you've got lead time elements in purchase order from paperwork process till stock put away. You've also got work order or manufacturing lead time from the time the order is released until it is put away in inventory by operation. That's define your MRP. Demand is something we talked about in terms of MRP before. First of all is what we call independent demand. This is demand that it has the whim of the customer. It's independent of other sources. The other is dependent demand. This is the demand that is derived from the demand for another source, in this case, the parent. So the demand for the component becomes derived from the demand for the parent. Some parts have both types of demand, and there are specific techniques for each in MRP. I'll talk about forecasting, and we've looked at the bill of material relationship. So you've got a BOM at the end item. You've got independent demand, which is forecast, and we apply intrinsic and extrinsic kinds of orders to those. And then you've got MRP dependent demand. Let's talk about some of the fields that are pertinent to MRP. There's the gross requirement. Gross requirement is the demand amount for each item, unified for a period. This is called the gross requirement. Gross requirement can be an exploded parent to a child, forecast, allocation, customer order, schedule order. These all are aggregated into this gross requirement. For supply orders are open purchase orders, production orders, or schedules, and these are considered available for use at the beginning of a time period MRP. This is also called on order quantity, paperwork released. MRP doesn't reschedule these, and MRP only suggests reschedule messages. Examples are scheduled orders, purchase orders, supplier scheduled work orders, production orders, the new production orders, repetitive distribution orders. These are all considered scheduled receipts. Let's look at the netting process. The netting process is this explosion of the parent through its product structure based on the gross requirements and those supply orders. So if we start off the gross requirement of level 0, parent E, we can see that that gross requirement is going to show up in MRP. If we've got 2 on hand and 25 scheduled receipt, that means we've got 27 available. That means we've got what's called a net requirement. A net requirement then of 73 feeds down into our gross requirement for the component A. If we have 5, then a 25, we have 30 available. Now our net requirement is 43. That 43 drives down. You can see how that then explodes down through the bill of material based upon the gross requirement, the on-hand, the scheduled report, the scheduled orders, and your net requirement. So that's the netting process. The projected or available promise is calculated as the quantity in period T equals the quantity in T minus 1 plus the scheduled receipts in T minus the gross requirements in T. So that formula then can be calculated for the first period as quantity on hand minus allocations minus gross requirements plus scheduled receipts plus planned orders. And then in subsequent periods, we've got the previous projected available minus gross plus schedule plus planned receipts. So that is what is used to calculate the available. And the available then is used to calculate what is called a net requirement. And a net requirement is simply a negative projected quantity on hand. This considers safety stock. If you elevate if you input a safety stock level, then the net requirement line moves up to that safety calculation or that safety stock value. The MRP record itself is very simple. You've got here a part, the lead time in 2 weeks, a lot size of lot for lot. We'll talk about order policies in just a second. We've got gross requirements. Those are sales orders forecast. You can see we've got 35 in period 5. We've got scheduled receipts, which could be purchase orders, supplier schedule, work orders. Then your quantity on hand then generates what is called the projected available. So if we look at MRP and its explosion process, we can see that we've got 10 at the beginning of period 1, 0 required in period 1. So at the end of period 1, we have 10 available. In period 2, we have 20 on scheduled receipt. So the 10 is going to carry into period 2. We've got 0 requirements, but we've got the 20 coming in. So our projected quantity on hand goes to 30. That carries to period 3, period 4. Now in period 5, we see that we have a negative projected available. That's the same as a net requirement. MRP doesn't like net requirements, so it's going to plan a receipt in that period and then offset by the lead time. MRP assumes you're going to do what it says, so it's going to come in period 5, and your projected quantity on hand is then going to go to 0, and you'll use that process out through the horizon. So here we've got a little bit more elaborate example. We've got a part 1, part goes into X, goes into Y. It's forecast as a master schedule for 1. And we've got 95 on hand, 20 allocate, safety stock of 10, lead time of 3 periods, and a lot size of 100. So what MRP is going to do is it's going to explode down gross to net net to the gross requirement. So you can see here in period 6 for part number 1 going into X, there's a 4 week lead time for X. You require 25 due in period 6. That means you got to have the gross requirement in period 2. You've got another 15 coming in, and we can go through that process of, in essence, exploding down the bill of material for those gross requirements. Now we've got the first period, 95 minus the 20, says we got 60 available. Then we got 40, 40 plus 180, 80 minus 30 is 50, 50 to 35, 35. Now we got a minus 10 projected quantity on hand with a net requirement of 20. That's because we put a safety stock of 10. So you need to have that net requirement take into consideration that safety stock. We're going to order in periods of 100, offset by 3 periods. It's going to come into the inventory and carry. That's basically how the MRP process works. You've got to be aware of bombs, items, sales, customer, gross requirements. So there's a lot of things that play into how MRP works, and each one of those could have an effect. If we look at the MRP grid, we can see that we've got basically the same thing. Gross requirements here, we have 2317 or 2314. You can see you've either got a horizontal relationship or a vertical relationship. There's your gross requirements. You can see the scheduled receipts come in. You've got a projected available. You've got a planned order. Then the order receipt. That doesn't show in the column representation, but then you've got details, which helps you understand exactly what the source and relationship is of those net requirements. So that's how MRP is going to work in QAD. A little bit about scrap and yield. Scrap is the ratio of the usable output of a process relative to its input. So if you've got a assembly that has a 5-cent defect on those, in order to produce 100 or 200, we need to start 210. So we put that in, and that then feeds down as a requirement, a gross requirement in that period. The yield is based on the parent component relationship. This is the percentage of the component that is wasted during an assembly of a specific item. So if during the assembly chairs 10% of the arms are wasted, to produce 100 units, we must issue 223 arms. So that shows up as a part of that parent component relationship. Let's look at orders, planned orders. Planned orders in the system are recommendations for additional supply to cover those net requirements. And if you look at MRP.DEET, you need to become aware of MRP type and MRP detail. Those will give you a good feel for how those are reacting. There is a planned order, but there's also a firm planned order, a planned order that has been frozen in quantity and time. And it's basically a tool for the master production scheduler to freeze in terms of quantity and time a particular planned order. So if we look at those 3 types of orders, scheduled receipts, planned orders, and firm planned orders, we can look at the relationship if they are automatically exploded or rescheduled by MRP. Well, scheduled orders, nope, those are already committed, paperwork released. It's not going to explode, and it's not going to reschedule. That would be the requirement of a human to do that. Planned orders, however, are both exploded and rescheduled automatically. But firm planned orders are, in fact, exploded, but no, the master scheduler has frozen those planned orders in terms of date and quantity. Allocations in MRP are termed as uncashed requisitions or uncashed requirements. shop orders, custom orders that are released but not yet picked or issued. MRP handles allocations as a part of the gross requirement for MRP. The effects on MRP are the timing of that allocation and the difference between the general allocation and detailed allocation. So general allocations are simply part of the gross requirements, whereas detailed allocations are the pick list, and this determines what is actually going to be physically assigned to the work order. A lot of people look at that in terms of an airplane ticket, and then you're assigned a seat when you get to the gate. Explosions. MRP explodes these bill of materials, the BOMP, in terms of either what is called a net requirement, net change, a regeneration, or a selective materials plan. And these go through the bill of material processor, and this basically tells how MRP to explode. The net requirement should probably be on a daily basis. Regeneration can usually be run on a weekend basis, depends on how you work it. But as Scott Delecky had told me just a couple of weeks ago on a webinar he had, this is getting less and less important because computers are becoming more and more powerful. And so I recommend that you run a regeneration as often as possible. There are what are called messaging that comes out of MRP. MRP goes through and it looks at the current order status and then recalculates what would be required to bring the orders back into phase with the current master production schedule. And these are done through these rules of misalignment. If we look here at our MRP orders, we can see that we've got a chair and an arm, goes 2 per, so we're going to bring down the requirements directly to the armature for 100 and 200. We've got 50 on hand. Those 100 is going to cover this minus 50 because if you've got an order in a period outside of a negative projected quantity on hand, MRP is going to tell you to expedite. MRP expects you're going to be successful with that. That 200 will then drive a projected quantity on hand of 150. 150 is going to drive to period 4. Period 5 is going to be 50. Now in period 6, we've got another scheduled receipt, but we're going to de-expedite that because MRP has enough in the projected quantity on hand in period 5 to cover the requirement in period 7 plus the scheduled receipt. So you're going to get a reschedule message and your projected quantity on hand will go to 0. Then in period 9, we've got 50. We don't even need that. So if that MRP is going to give you a cancel message. So those are the 3 types of what are called rules for misalignment. So you can see that the quantity and the due date of those orders, whether they purchase orders or work orders, are critical to the way that MRP is going to calculate that re-explosion of the system. Action messages, by virtue of those explosions, you're going to have action messages coming out of MRP. Do those action messages every day. You got planned orders, work order release, reschedule messages, planned order, work order approvals, purchase orders. There are over 50 action types that come out of MRP. You can see the create 1002, de-expedite, expedite, cancel, but there's a whole bunch of other action messages that can come out of MRP, and you need to pay attention to those every single day. So MRP assumes you're going to do what it says. It assumes you told it the truth. It assumes that it's easier to expedite an order than to place a new order. And if your lead time said 1 week, it's going to take that 1 week to do it. And if it tells you to expedite or delay a scheduled receipt, it assumes you were successful at that. It also assumes that you have told it everything you know. Most companies I go into, that is the primary problem. You have not told the system everything that you know. QED MRP is very flexible and can handle almost every single set of circumstances for your product, whether it's yields, whether it's scrap, whether it's schedules, whether it's capacity. So you need to tell MRP that you did it. So let's look at how to make MRP fail. Everybody knows about control files. So there's a number of control files that have to do with MRP. We see the 23.14 primary, but all of those other control files play into how MRP is processed. So if you look at 23.24, we can see that's where your MRP horizon is set. There's your order release horizon. So the planned order release comes within, in this case, 7 days. You're going to get action messages. If you want op-based yield to calculate the 5 elements manufacturing lead time, you check that box. And there's dynamic time fence management that allows you to manipulate the time fences for MRP. There are lots of other control files that affect MRP functionalities. You should understand how all these settings can affect the processing of the MRP explosion process. There's the item data. Item data has to do with your part, the quantity, the planning elements. Those are all defined in 1.4.7 and 1.4.17. So that if you don't have sites, you use in 1.4.7. If you have different sites that you're running MRP in, then you should make sure that those 1.4.7, 16, 18, and if you use service and support 3.11.3.9, you should try to make every effort to ensure that the product master records coordinate with the PTP and the PTI, the part planning and the part inventory records. That can cause MRP to also have issues. So planning elements that can affect how MRP processes, primarily found on 1.4.7. There are planned orders, lead times, order policy, safety stock, phantoms, lead times, minimum, maximum order quantities. So there's a lot of information that can cause MRP to process differently. You really need to understand how each one of those plays in that explosion. One of the primary ones is lot sizing. Lot sizing is how MRP is going to address those gross requirements. So if you look at a quantity against a cost, you can see that it is going to have a decreasing cost the more you order. The less you order, you're going to have it around more often. So you're going to have a higher carrying cost. If you add the carrying cost to that order cost, you come up with what's called a total cost. And if you look at the total cost and graph those across the quantities, you can see that you have this what's called a total cost curve. That total cost curve then drives down to the most economic order quantity for a particular item. If you look at that in terms of not the graph, but a formula to calculate, you can calculate it either in terms of dollars or units. If you look at the annual dollar usage setup, annual carrying cost and unit cost, you can calculate that, but you want to calculate the EOQ in terms of formulas to input into 1.4. Now be cautious, this total cost curve can be fairly flat across that minimum point, so don't try to take EOQ out to 10 decimal points. There's your order policies in MRP, discrete, lot for lot. That means if you got a requirement, you're going to order. That's usually a good idea for end items. You've got fixed order quantity. This is that EOQ we talked about. You've got lot size varying by item. And then you've got period order quantity. That's where the order quantity is equal to some end periods of net requirement. Then you've got your order policies, order modifiers, max, min, and multiples. And there are other types of order lot sizing methodologies: least total cost, least total cost, least unit cost, part period balancing. I've read some of the literature that says part period balancing is probably the most effective lot sizing tool. Not available on QED, but I have seen it ordered. So lot sizing issues that can affect MRP. If you don't know how to calculate EOQ, that's going to be a problem. You need to understand your order modifiers, your min requirements if you got them from suppliers, order multipliers from the suppliers, and the incorrect placement of POQ orders. Now, I had one company that had every single part number as POQ7, and they wondered why MRP didn't run properly. Safety stock. Safety stock is defined as the amount of inventory we carry to guard against variation. It's based upon the variability of demand, MAD, or standard deviation, the frequency of ordering, how often you place an order, how much service level you want to maintain. The more service level, the higher safety stock needs to be. The length of the lead time of the variance between the forecast and the lead time period, and then your ability to forecast and control lead times. Those are all going to play into how you measure that safety stock. So you got two fields in QAD to do that, safety stock, but remember, if you put in safety stock, you bought that inventory. So it's a cost to the organization. Safety lead time increases the offset between the planner to due date and planner to start date. And that can cause issues also. I'd be very cautious with safety lead time. So safety stock issues that can affect the MRP, not understanding the service factors, not measuring mean absolute deviation, your lead time to forecast ratios, not measuring forecast error, use of safety lead time. These are all things that can cause safety stock to adversely affect MRP. So safety stock is the responsibility of both the planners and the buyers to update. Remember, you want to make planned lead time as close to possible as actual lead time. Again, if you put in safety stock, you just raised the zero net available in MRP calculation to that value you bought it. Forecasting. Forecast is part of that gross requirement. Sales operations planning is a kind of a new concept, not real new, but it starts off at that top level of the closed loop system: business planning, marketing planning, and production planning. There's a new tool available through QAD called Dynasis. QAD bought Dynasis a couple of years ago, and this is the tool that is used now for that SIOP processing and sales and operations planning. If anybody has a chance, go in and read anything you can by Dick Glenn. He's considered the father of SIOP. And if you don't use Dynasis, the QAD supplies you with distribution planning, production planning, resource and operations planning, which assist in that sales and operation planning process. Forecast maintenance is input in 22.1. Typically, it is going to use in this case, an exponentially smoothed average based on an alpha factor. You input the item, the site, and the year, and then load in your periods across the horizon. That then drives the master production schedule, which drives MRP. You can use 22.7. These procedures allow you to use historical sales data to create multiple forecasts and so store those forecasts within the system. There's 6 standard methodologies that you can use, and there's an unlimited number of self-defined forecast methods. If you need assistance with that, you call us or get a hold of QED, and you can do that. But that is an excellent tool to do forecasts for budgets, for quarters, for departments, etc. You can forecast within the QED forecast system and keep track and do some pretty good analysis and reporting with that. So why does forecast make MRP fail? Well, if you try to forecast dependent demand, don't try and forecast dependent demand. Only forecast independent demand. Don't confuse the forecast with sales budgets. You need a consensus quantity as the forecast, both subjective and objective forecasting, modified by intrinsic and extrinsic forecasting. Not having the appropriate math model. If you have a math model averaging over 6 periods and you really how to have exponential smoothing, MRP is not going to work well. Not using 22.7 is a big problem. Remember the first principle forecast, they're always wrong. Forecast focused on shortening lead times, not the perfect algorithm. That way forecasting becomes less important. So sales orders can play havoc on MRP. We input demand by sales order in 7.1.1. This creates a gross requirement demand in MRP. You can see the gross requirement in MRP comes from the line item, and we can see that show up in the MRP grid as a gross requirement in MRP. So the sales order header, due dates that are defaulted down into the lines. Here's where we consume forecast. Again, defaulting down the lines, allocation days and status, along with the line item, which is your dates, your quantities, allocation quantities, unit of conversions, etc. So sales orders are going to have an impact on your gross requirements. Sales order packing and shipments are going to have a significant impact on your order policies or in the MRP. This is going to decrease your MRP on hand. Okay, so MRP can't see it anymore. It's going to increase accounts receivable. So shipping affects quantity on hand, gross requirements, allocations, quantity picked, shipped, and pending, required dates, and the timing of shipments. I saw one company waiting till the end of the week to accumulate shipment processing in the system and running that change daily, and they couldn't figure out why MRP wasn't working. The perpetual record is the quantity on hand. That's where MRP starts. If that's not accurate, then the system doesn't work. It is the continuously updated quantity on hand and the transaction of how it got there. It's where MRP starts. It's maintained in transaction history. If you've got allocations, order policies, you can see that that on-hand value is updated by those transactions, and that perpetual record at any point in time needs to be at least 98, say 100% accurate in order for MRP to work properly. For transaction control, there's hundreds, sometimes thousands of transactions that are affecting MRP, orders on hand, transfers, issues, etc. These are the primary transactions that are going to affect your MRP calculations, cycle counting, purchase order receipts, sales orders, inventory transfers, work order transfers and receipts, purchase orders, etc. So these all have to be accurate and timely. Cycle count process, if you use cycle counting, this is going to help you maintain the quantity on hand. If you do physical inventory control, QED has a whole set of transactions that allows you to look at physical control. I'm not here to say that you should, but Eagle, Freedom, Automated, anything that's got to do barcoding is going to give you better transaction control. So the perpetual record, quantity on hand, transaction, cycle, physical, perpetual records, these are all going to affect your MRP calculations. If you've got purchase orders are part of that scheduled receipt. You've got header and line data for MRP. You've got your purchase order maintenance. You've got your line. And you can see here in the scheduled receipt, that's where your sales orders or your purchase orders are going to show up in the MRP. And if you receive those, the receipt process is going to take it away from the scheduled receipt and increase that quantity on hand at the PO line. So the whole processing of purchase orders is going to affect how you do MRP. So purchase orders, the accuracy of on hand and due dates, receiving, returns, ASN, the supplier schedules. It's ultimately the buyer and the scheduler's responsibility to make sure that those quantities and due dates of purchase orders are accurate. Work orders feed off of item product structure, which we've talked about. Work orders and routers. You've got 16.1, which is the header. You got 16.13.1, your work order bill maintenance, which allows you to manipulate the item component quantity required, component due dates, allocations. And then the 1610 is what reduces the quantity on hand of the component in the MRP grid and eliminates the work order component detail. Work order receipt shows as a RCT-WO in 3.21.1 transaction by item browse, and this moves from the scheduled receipt column to the on-hand quantity in the grid. So you can see it reduces the schedule and increases the quantity on hand. The elements that affect MRP, you've got a process of 16.1, 16.13.1, 10, 6.6, and 16.6 and 16.11, and that's where you drive all of the due dates and order quantities. If you don't do a good job of that, improper use of work order types, statuses, due dates, release dates, all of those are going to play on how MRP is going to treat those work orders. Capacity requirements planning. Remember, MRP is what is called capacitive insensitive. That's why you have to do resource requirements planning above MRP and CRP below MRP, so that you ask yourself, are the rough cut resources available, and then drive that down into master scheduling. Master scheduling drives material requirements planning. Material requirements planning drives CRP. You balance the CRP so that you see what the capacity and load is generated by your MRP process, and then review your input and load summaries to make any modifications that are required to your system. So, in summary, there are a lot of things that affect MRP. These all tables are part of that. It helps to understand all of these tables and fields to make MRP plan correctly. There's a lot of data that is required for MRP to calculate correctly. Those of us who use QAD know that sometimes it's a pain to get the data in on a timely basis. So 32Soft has a whole series of 32Soft loaders that directly relate to your ability to timely and efficiently update that MRP data. So the 7 most significant factors are your lead time accuracy, on-hand accuracy, what forecasting you're using, history and seasonality, your open sales order, purchase order, and work order accuracy in terms of dates and times, and your capacity so that you can look at CRP in terms of what that MRP output is. And then finally, your BOM and subassembly dependency. Remember, there are limits to MRP. It is capacitive insensitive. It ignores critical resources. It's overly demand sensitive. So that's why we have time fences in there. And it assumes you've given it 100% accurate. You've told it everything you know. I get so upset when I hear people say, well, MRP doesn't work. The system doesn't work. No, it's the people that operate MRP that make it not work. So we've talked a lot about what various factors are in MRP. There's over 119 specific areas, menus, and functions in QAD that affect how MRP works. Any of these can cause MRP to calculate differently or even incorrectly. Understanding the concepts and the correct application of these concepts can make MRP do what is intended, create a plan that can be executed successfully. So what did we take away? How to use MRP and the factors that can adversely affect the impact of accuracy. MRP is hard. It takes a concerted team effort to ensure understanding, accuracy, timeliness, consistency in planning and execution. So if you've got any questions, please send myself, Denise, Alex, Nancy, a quick email, and we'll be glad to address any questions. Thank you for your time.